Good evening and welcome everybody to N-Simplex Pachinko. This is Obi-Wan Pez. Gonna be doing some math tonight. Welcome back to school, those of you who are at school. And welcome back to the program, anybody who is returning. Self-taught Calc 4, oh man. Vector Calc, I always say is kind of very similar to like Calc 1. It's the partial derivatives, like the special rules of partial derivatives were just really cool. So I always was attuned to that. Got very quickly, got the basic rules down. It was the Rolle's theorem, Green's theorem stuff way at the end that kind of maybe not like it quite as much as I probably could have. But glad to see you all. Yeah. Glad to see you all here. Amogus, Blamelin. Paying the distance learning fee, yeah. Yeah, just so vector calculus in general is not really any harder than the original calculus. It's just, again, you've got more variables. But the most basic thing that you can say about it is, let's not actually write on this. Let's not write non-elementary geometry on it. Right, so if you want to do just basic stuff for this, $500 US per class to do distance learning, yeah, that sounds about right. Or that's just the distance learning fee, isn't it? Or is that everything? So the partial derivatives, we look at this. Have this kind of curly d instead of using the original ordinary derivative. So when you're just writing it out with variables, it doesn't look any different. But if you say that y is equal to 10x plus 6t squared, then what would happen is in an ordinary derivative, your dy dx would end up becoming 10 plus 12t times dt dx. But in partial, what we're saying is that we don't actually care what the change is in terms of... We don't actually care what the change in t is with respect to x. Or we're going to say that that change that we're making is going to be 0. So it's a simplification. You say, okay, partial y with respect to x is going to be equal to, here the derivative on x is being taken exactly the same. So you just get 10. But then over here, you end up with, I mean, essentially what happens is you do get this 12t part, but then your dt dx is 0. So that just kills that whole term. Basically what it boils down to is you treat all other variables other than x treat all other variables as constant. So y is our function in this case. That's why we actually kept it around and said we want dy dx, because y is a function of something else. It can be. I don't really know all that much in terms of like applications to programming specifically. Something just came up for an installer, so I will keep that in the background, and hopefully it won't interrupt the stream. So, if anybody has any questions for tonight, feel free to let me know. I have not watched House of Dragon. I'm assuming that is, and maybe this is a big assumption, but I'm assuming that is related to Game of Thrones, which I also have not watched because we did not buy into, what was it, HBO? Netflix? Whichever one it's on. We bought into a lot of other streaming services, unfortunately. Wasn't really into Breaking Bad, so no. And of course that's on me, right? Probably would have liked it, but let's see. Lately, I've been getting into Orville because I haven't watched any of it up until about 2 weeks ago, and I'm already on season 2. Let's see. I have. Here we go. I started to watch Tales from the Loop because I played the TTRPG that goes with it. And I've only made it through part of episode 1, apparently. Because I keep getting distracted with other stuff. And I keep trying to watch it, but I keep getting distracted. I did not watch The Boys, although more people are starting to recommend it. I think my issue with it has just been the... I don't really like the like wild super anti-hero. Like, these are bad people. I don't really like that too much, but that's just me. Division and subtraction. So I believe that they are a notational construct that is convenient. Because all we need for fields, and we talked about this last time, all we need for fields are like 0 and 1 and addition and multiplication. What movie am I anticipating? You know, I haven't really been paying too much attention. I usually there has to be something, right? Like I just really haven't been paying any attention lately. I've been too busy like getting ready for school and stuff. Really? Oh no, you can all hear me. Okay. I just can't hear myself now, which is really off-putting. I have not watched any of the Avatar stuff, so not knowing the TV show, which again comes to me highly recommended. Not having watched the TV show, I'm not really paying attention to the movies, uh, but maybe we'll get there. So given that your field requires 0, 1, and addition and multiplication, and then when we use this, we end up with the additive inverse. So a plus a negative a equals 0, and a multiplicative inverse where a times 1 over a is equal to 1. Right, this is what I start seeing and say, okay, well, if we've got this addition of two numbers which have this property, sure, you can say that this is subtraction. But like I said before, it's just kind of a notational thing. It's useful, but at the same time, I don't think that if you're trying to do any like rigorous mathematics, you don't need it. And same with the division. You don't actually need division in order to do the rigorous proofs in mathematics. It's a notational construct. It looks kind of nice, so that here doing a divided by a is, it works. But I mean, that's also the same as asking, like, does the number 10 exist? Like, you can prove it exists by way of doing this other stuff, but, like, do we need it to be that particular number? Yeah, I mean, you got it. It's gonna take a bit of work, but it'll be worthwhile. You might have to stop watching some videos online and stuff like that, but you'll make it work. Yeah, my spouse and I were just talking about this actually. Although she took she and I both took calc in high school, and There we go. Okay. Jeez. That took way longer than I needed. Oh yeah, you don't want to get that beaver fever. Yeah, Gerardia is the biggest problem of um, drinking, wild water. Mostly because like all of the animals defecate near the river, so when you drink that, it's got all sorts of nasty bacteria in it. If you can find a creek that comes from like a natural spring, and it's guaranteed that there aren't any animals, you know, putting their waste in it, then you'd be all right. But that's a pretty hefty gamble if you're like half a mile downstream from where you think the source is. But yeah, up in New Hampshire where we're from, there's a lot of beaver dams um, in creek areas, so you cannot drink the wild water. You have to bring in your own, or you um, have to bring in your own, or you have to bring a filter. And so like we went into the White Mountains, um, me with my parents and my brother, and um, like uh, the White Mountains are pretty big mountain range. Yeah, yeah, it's pretty nice when the snow's up there. This for us was like after school started, or like just before school started. So we took like a weekend and decided that we were going to hike Wildcat Mountain. So it's this big loop that goes like from the parking lot the up a hiking trail. It goes up over Wildcat Mountain, up over whatever the next one is, and then down the other side, and then back along the road to the parking lot. And so we brought all of our own food, all of our own water, all that good stuff, and we figured we'd try, in addition to having our own water packed in, we want to bring the filter because it's, you know, you go hiking, you bring a filter. Especially since this was a multi-day thing, and we were not going to bring like 5-gallon jug. That just was not happening. So each of us had our own personal, Nalgene size thing, and little water bottle, and we just kept refilling out of the creek while we were down there, using the charcoal filter. But yeah, it was nice. We we woke up the first morning to our father just like jumping in the creek for a bath. We're like, oh my god, I hope nobody walks over here. But yeah, I was like, I'll pass, thanks. And he walked out of there. It was so freezing cold. He was shivering coming out. It was like, oh man. But no actual, like, no problems or anything like that. It was, we had, um, we were gonna walk so much during the day that he heated up almost immediately. So, and this was, September, yeah. So I think it was after school, September, October, which the leaves are turning right about that time. So somewhere around, this was somewhere around my brother's and my birthday. We were both born in, late September. Well, keep in mind this is September, October in New Hampshire, so it's not too bad. But yeah, in Montana, yeah, it'd be pretty nice. And again, you were in Virginia, so yeah, it's rather warm. And it's not even the heat. It really is the humidity that just, I mean, it's hot and that's bad, but the humidity just drives it up a whole nother level. So no, I personally have not been to Montana. My aunt lives out there, and we still have to go see her. Um, Still haven't been. Oh. Yeah, I'm sure that the grizzly bears are very nice to see from a very long distance. We did see she's in Grand Rapids greater area, somewhere in there. Glacier National is not too far for her, and so she when she's feeling up to it, she goes and hikes there. She's also like she took she took my dad and my mom out there because they're really big into hiking. Um, yeah. So um, our hiking trip on Wildcat was fun. We ended up having this, you know, we went out, started going up the side of Wildcat, and the sun was starting to set behind the mountain, and we're like, this is gonna be fun. So we had to move probably about a half mile along the trail and up um, before it got dark. And so we eventually, when we peaked on whatever the first mountain is, I think it's Wildcat. When we peaked on Wildcat, we started coming around one edge, and then we were starting to head down into like the forest when it just went completely black. Can't see your hand in front of your face. Had to break out the headlamps. Um, and we made about probably another tenth of a mile, maybe that, on the trail before we found like this little tiny alcove that we were like, well, better than nothing, and pulled over, dumped all of our gear, started setting up camp, and started making dinner. Um, this is story number 576 as to why I'm getting cancer someday. Uh, my dad's got American chop suey, which is, if anybody doesn't know what that is, also known as goulash. Basically, tomatoes, hamburger, and pasta just mixed together. So this is already pre-cooked. It just needs to be set in a pot. Um, so my father uh, takes this freezer bag and sticks it in the pot of boiling water, which almost immediately ruptures the entire bottom. We now have a pot of boiling water, goulash, and some plastic in there. Oh, did I mean somewhere else? Michigan, maybe? Is that what you meant? Yeah, Grand Rapids is in Michigan. I messed that up. Falls? Great Falls? Yeah, Great Falls, Montana. So, Great Falls greater area. That's like the nearest thing. Uh, I misspoke, two curbs. I said my aunt was in Grand Rapids, but that's in Michigan, not Montana. Yeah, so my aunt lives somewhere near Great Falls, Montana, near Glacier National, which is a beautiful place that I still have yet to go. So we do want to get out there sometime, but like we just, you know, we didn't really have the time originally, and then it's a really long trek comparatively for somebody's gonna hate me for this, but not a whole lot of payoff. I don't mean that in a super mean sort of way. You know, it would be great to go see my aunt. It'd be great to go see Great Falls and um, yeah, yep, Great Falls and Glacier National Park. It would be well worth the trip by itself, I'm sure. I'm just kind of ribbing a little bit. It's okay. And Helena, yeah. Well, if I go to Helena, Montana, I'm gonna have to stop by and see Hank Green over there at DFTBA. Oh, yep. Our speaking of, at the Crash Course coin, which is basically signifies that I have donated this year to Crash Course to make good content. So go Crash Course. Don't go east. Yeah, so my aunt used to live in Minot. Used to live in Minot, North Dakota, which I believe has the distinction of being the coldest place where people actually live on purpose. Um, uh, Minot, North Dakota, I believe, had temperature, including wind chill, down to minus 110 over most of the last several winters. And yeah, she was there because my uncle is a doctor for Air Force, I think. I think it's the Air Force, and so he was stationed in Minot, North Dakota, and yeah, woo. Yes. So, two curves. Finding the minima of functions with periodic components. So you have to check those, and if you know what the period is, so like again, like you said here, if you have sine of x times x or something like that, you're going to right, yeah, that particular one has no global minima because it's just going to go infinitely as you go out further. Um, but let's say it's a function that has northern Idaho. Okay, check. So if this is a periodic function and that is its period. I'm sure somebody's going to take exception, but okay. And we'll go like that to make it actually work. Okay. So if you know that this is the function and that is its period, whatever it might be, all you have to do, because again, if you know that this is the period, you can just say, well, this is going to get copy pasted as many times as we want in both directions. Oh man. So I mean, literally, I could copy paste this. Oop. Yeah, I'm a little low. It's all right. Oh. All right, whatever. It's close enough. That's good. Blainland, I can also say that one of my friends said the same thing about Crater National. Oh, sorry, Crater Park, whatever the big crater is in Arizona. He said it felt like a real scam because it was for profit. It was not um, it was not a national park, so it didn't have like the didn't have park rangers there. It just had like a bunch of people who were there for profit. So, sort of. The problem is that you can't necessarily just decompose it. That's going to be sort of a naive setup, because if you decompose it, then you're saying that like if you try to find the minima of the individual components, then you're not saying that the function is equal to 0. You're saying that a part of the function is equal to 0. And who knows what the other part is, right? So you have to say, like, okay, this part of the function is equal to the negative of the other part of the function. Or the total sum is equal to 0. But anyway, if this is your function and you know what its period is, what you can do is say, okay, I just want to focus on the simple period, the one that covers 0, wherever that is. Yeah, you got the Grand Canyon, that's about it. I worked for 3 years on a project in Maricopa County, Arizona, from Mid-Atlantic, and well, maybe, but it all depends on what you see and when you see it, and what you do there. So if you're going to do the hike to go down and then back up, that's kind of cool, especially if you like hiking. And then if you know your geology, it's just like no, I've only ever been to Washington and Oregon on the West Coast. And that's basically it. I have been to the airport in Texas. I was getting a layover for like an hour before I went on to Hawaii. So anyway, we'll eventually get this thing done. It's fine. So you're going to be looking for these parts. And you want to know when it has its maxima and minima for this particular function. So you set the entire function equal to 0. You say, okay, if it's got like multiple parts, and some of which are periodic, in this case it is a full periodic function, but it's going to be a composition of multiple periodic functions. So this would be like a yeah, this example would be true periodic, but for something like y equals 4 sine of x minus 3 sine of 2x plus, I don't know, sine of 4x or something like that. You could do something like this, and one of the other keys of numerical analysis is that actually, if you do a Fourier transform, you can eventually end up with a like if it is a true periodic function, it doesn't actually matter what you're given. You can always make it the sum of sine functions with multiple periods. Now, they may not be integers, right? Some of them might be some of them might be I'm getting far too distracted. Some of them might be rational or irrational numbers, and that's fine. But you will always end up with a periodic function that is the sum of multiple other periodic functions. Yeah, I do like Vermont. Being our neighbor, Vermont was always a place that we went through, and hardly ever a place we went to, which is too bad because it was really nice. If you do go to the Northeast, I do recommend Maine, New Hampshire, Vermont, one of those three. Much easier now that I've got my glove on. It's very hard to see those fingers. One of those three. So Maine, New Hampshire, Vermont. Go to a sugar shack. If you like maple, you will not regret it. And basically, if you go anywhere in the Northeast for a sugar shack, you will not be disappointed. But Maine, New Hampshire, Vermont, in my humble opinion, have the best are the best three states to get your maple syrup from. Now, I might be a bit biased as well. And I'm sure Canadian maple syrup is awesome too. Yep. So I don't think that I've had Washington maple syrup, not really. Just because it's, you'd have to ship it so far. And like, why would I do that when I live on the East Coast? Okay, so, two curves. If it is a combination of periodic and non-periodic, then you will end up with something. So let's do like one of the classical solutions to differential equations, right, is e to the negative x sine of 2x plus e to the negative x cosine. Oops. Cosine 2x. I think the District of Columbia should have a true, and Puerto Rico and Guam, if they want to, should have the ability to cut through the bullshit and have a truly honest election and have a truly honest campaign and discussion about the pros and the cons of being involved in getting statehood, in doing all these things, right? In being everything. Here are your options. Let's lay them out. And have a ranked choice vote on what the two top options should be. Once they have a ranked choice vote of the two top options, then they should have a vote between those two as far as what they should do. It is up to them. Let them figure it out. But do not start throwing propaganda around. All right? I'm not talking to you because you're not doing it, but so Blaine, I was only in Seattle for 1 week, and it was sunny the entire week. So I think it was lovely. Other people will say, "Oh, it was so awful," but like, yeah, it was fine for me. All right, so, yeah, two curves. So, so let's look at this from, let's do like negative pi to pi. All right. So over that particular interval, we want to know where the sure, let's just do this. We want to know where the minima and maxima are for this particular function between negative pi and pi. Now, I am going to keep this as a closed bracket. When you are trying to find the minima and maxima of this function, you should technically be looking at this on an open interval. and then check x equals negative pi and positive pi. Now, why do I say that? If you remember, or if any of you all remember why that is that you need to technically do that, go ahead and throw it in chat there. But for this, right, you'd want to say, okay, dy dx is going to be equal to, and then here we have to do the whole product rule. This is going to take a minute, so, you know, be right there. So here we get 4 times negative e to the negative x times the sine of 2x. Okay, and then we get plus 4 e to the negative x cosine of 2x times 2. Okay, so that's for the first one, we have the product rule. And then plus, we get product rule for the second is going to be 2 times negative e to the negative x times the cosine of 2x. Okay, plus 2 e to the negative x times negative sine of 2x times 2. Okay, so the first one here ends up being a negative 8 e to the negative x sine of 2x. If I miss anything, let me know. So it's not that their derivatives are equal to 0. But yes, you are right in that you do need to check their values because they may not be in... Sorry. You're correct on one count. And that is that they could still be extrema for this particular function, but we're not going to find them from taking the derivative and setting the derivative equal to 0, right? Because like I did actually in the picture, right? In the picture here, we have that the endpoints are curved up or curved down, depending on which side we're talking about. So yeah, that's one count. Now, what's the other reason why you're not allowed to just say, oh, it's just over the brackets and that's it? There's another rule-y type reason. All right, and this one here is going to be a plus 8 e to the negative x cosine, cosine of 2x. Did I ruin this? No, okay, I did not ruin it. Good. This is going to be a negative 4 e to the negative x cosine of 2x. And this is going to also be a negative 4 e to the negative x sine of 2x. Do we know any good tourist spots to watch the autumn leaves? Yeah. So if you are going to do your leaf peeping, as they call it in the Northeast, you are going to want to go really anywhere. Anywhere in New England is good, right? Like good. If you want really good leaves, I would say that you want to go to like anywhere north of Connecticut really does have awesome leaves. If you want like a really pretty space by itself, like to go and yeah, the autumn leaves here in the mid-Atlantic are pretty bad too because we have a lot of flowering dogwood which kind of just turn yellow for about 2 days and then they turn brown and fall off. Or they go straight to brown. And it's just like, ugh, come on, man. Put a little effort in. All right, here we've got a negative 12 e to the negative x sine of 2x and a plus 4 e to the negative x cosine of 2x. All right, so if you want some place that is like really pretty all by itself, like that you don't necessarily need to do anything, I would suggest going to like the White Mountains, the Green Mountains in Vermont, anywhere in Maine. If you go up to like the Sugarloaf area, where now this is really far, by the way. It was like a 3-hour drive from my parents' house in New Hampshire. So we're talking like an hour in to Maine and then 2 hours up. So you could get into the hills and go out and just see, because you can see to the horizon 20 miles away. I have been to Canada in that I have been to Niagara, crossed the border, and came back. I did not do the... Oh, and we did go to a couple of places along the west coast when we were doing a boat tour, a cruise, where we went to a few of the glaciers along the way. So, yeah. So we like parked in British Columbia and took a plane back. So we didn't really like stay in British Columbia, which is really too bad because it's a nice place. We could have stayed there a little bit longer, but we needed to get home and back to work, unfortunately. I do highly recommend, and you guys are awesomely chatty tonight. So I have seen the Northern Lights, and I did not cremate St. Mickey. Here's the weird thing. I have not seen the Northern Lights in... I have not seen the Northern Lights in, like, Alaska, Canada. I have seen the Northern Lights in New Hampshire. That was not supposed to happen. It's one of those weird things where, like, there was a solar storm, and it hit just right that the Van Allen belts pulled really hard down into the northeast. And like I said, this wasn't something that kind of should happen. It just happened this one particular time. I was at my parents' house in 1998 to 2000, somewhere in there. Yeah, so it was 98 to 2000, somewhere in that region. And we were out for dinner, and we were driving back through this town called Stratham, New Hampshire, Greenland Stratham, so right on the border. And there's this field that's just out there. It's 100% clear. There's no lights, and beyond the field is Great Bay in New Hampshire. There's nothing out there. It's all salt marsh. So nobody lives there. There's a train track, and that's about it. And so I started seeing what looked like green sheets going across the sky, kind of fluttering a little bit, and I was like, what is that? And I was like I'd taken a bunch of I'd done a bunch of reading in astrophysics and science and stuff like that. So that was really my forte, was like astronomy and astrophysics. And so when I saw this, it took me a minute to realize what this was, because, like, again, you're not supposed to see this in New Hampshire. And then there was this fluttery green, and then there was like a spark of orange, which started popping up occasionally, and then going away, and it faded back. And then just the green sheet kind of look was playing across the sky. And I like yelled at my dad, pull over, pull over. He's like, what? I was like, it's it's the Northern Lights, and he's like, yeah, bullshit. Come on, no way. So he pulls over, and we look at it, and we're like, oh my god, it is. So then we finally, we stopped for like 5 minutes, and we just looked at it, and then we were like, we gotta go home because we gotta get like the. My dad's got a telescope. We're gonna tell all the neighbors to shut their lights out. So we got home. He called up all the neighbors. There's like 3 houses right in a row next to ours that were, fairly recently put in at the time. And so he calls up all the neighbors and he tells them, turn out your lights and get outside. You can see the northern lights. And they're all like, okay. So they all shut out their lights. And we hear all the way at the end, the last house is a kid who, and 98, 2000, I'm late high school at this point. It was October, and they've got a kid who's like 4 to 6, somewhere in that neighborhood. So we just see the door open, 3 houses down. It's like 500 feet away. This is like, it was an open field of, I don't know, 4 acres or something like that. So we can just barely see them coming out of their house at the end of the field. And then I hear this little kid go, wow. So it's just, really awesome to be able to see it, and even better to like have other people see it, because especially when what's going on, you can be like, look at this is awesome, and explain it to people and things like that. So we didn't actually interact with the other family, but just to tell them, hey, the northern lights are outside, and they're like, what? That was a pretty big, like, it's a weird thing. I think maybe that's probably one of the ways in which I really like being a teacher, is seeing that moment when everybody else is like, oh, I get it. So am I gonna go to Washington State again? Yeah, probably. I would bet money that we're going to Washington State at some point, just because it is so great. We really liked it. And all right, so I'm gonna pull out a 4 here and e to the negative x. Now, actually, this one's kind of easy. I decided, yeah, okay. Oh, that'll still work, maybe. That's the other thing about the Pacific Northwest. I'm going to encompass Oregon, Washington, and British Columbia kind of all in one group. That I think there's going to be something different every time we go. Especially Portland in Oregon, because they are proud of their weirdness. I mean, when we went, the city itself was super clean. we could get anywhere we wanted with public transport. Portland. So again, when we went, so that may not be when anybody else went, when your opinions were formed. Yeah. So when we went, this was 2007, 2008, something like that. Um, it was super clean. We could get anywhere on public transport, and the food was basically unmatched anywhere else compared to what we had at that point. Where, like, any kind of food that you want, it is available. It might be like a mile away, but you can get it. Well, sorry to hear that. All right, in this case, we got 0 is going to be equal to 4e to the negative x, which can't happen. So that's just going to be a trivial, a non-existent solution, not trivial. Over here, we've got that, or 0 is going to be equal to negative 3 sine of 2x plus cosine of 2x. At this point, there's a couple of things that you can do. 2012, that's too bad. Did they elect a bunch of people who decided to take money for themselves instead of giving it to the people? Oh no, the dreaded Californication. Alright, so for this one, we're trying to figure out when the sine ends up being a third as large as the cosine. Or I guess we could do the tangent, so that makes it a little bit easier. We want when tangent of 2x is equal to positive 1/3. I mean, like I said, you know, that opinion was formed in pre-2012 there. It was around 2008. One of my friends got married up there, so... And like I said, it was very beautiful. We liked it a lot. But, you know, places change, I guess. Alright, so here, our 2x is going to be between... Oop, no, hang on. Our x was going to be between negative pi and pi. We said inclusive, but again, we can... Good job, Amogus. Alright, 2x is going to be between negative 2 pi and 2 pi. And our tangent, oops, let's make straight lines, because that's way better. Really? Now you're not going to straighten the circle? There we go. close enough. So we have a tangent value of 1/3, so we're going to get a line whose slope is 1/3. And that's, you know, give or take. So, 1, 2, yeah, that's close enough. So where's the slope equal to 1/3? Well, set it equal to 1/3 like this, and then, yeah, you let Microsoft Whiteboard do it. You just draw a sloppy circle and then let it go, and it does it for you. Am I gonna... So here's the other thing, Blaine, that I'm probably not gonna move for a while. And if we move, like, permanently, it's probably gonna be back to the northeast. And most likely it's gonna be when the kids are out. Because the cost of living up in the northeast is a lot less than it is in the mid-Atlantic. Now, granted, we could find a place in, like, Pennsylvania, you know, middle of the woods, Pennsylvania, and that would be fine. Maybe we could also find a place in, you know, Maryland, West Virginia, Virginia. That would be just fine. But, you know, it's kind of hot here. We much prefer the weather in the Northeast, and that is including the snow. That is despite the snow. So, you know, we've got another good 25-ish years until, you know, retirement, and then I'm still going to be able to do whatever I feel like online, and maybe write a book in mathematics, do a textbook, and or just write about my experiences. I was talking with my faculty advisor slash boss slash whatever today, and she was like, you know, you're getting really excited about this. It seems like you might be interested in doing a PhD. And I'm like, no. And that would be as much fun as that would be. As much fun as that would be to write a massive dissertation. Whew. I'm not sure I want to do it. Alright. So we can get an angle here. We can get an angle here. And we can't get an angle here because that's beyond 2 pi. So let's back that one up. We can, however, get an angle here. And we can get an angle here. If we're saying we want explicitly from negative 2 pi to 2 pi. Remember that we're trying to solve for 2x at the moment, even though our initial interval was from negative x to x. Yeah, I am a fiend for like all different kinds of food. Right now, I've got like my eye set on this. So I really like the Chinese food we got up the street. I need to cut down on sugar, like really harsh. I did, in fact, I don't know. I don't know if it was even noticeable. But I cut down on sugar really hard from beginning of July until like a couple weeks ago. And there was a good month where I dropped 20 pounds in a month. I also restarted my karate, and so that was like, it was really fast. But I was determined that I needed to get myself under control, and so I stopped eating like all sugar unless it came from fruit, or maybe like complex carbohydrates. So, you know, pastas and like breads, I was okay with as long as it wasn't super sugary and all that. And I didn't eat too much. And like really not a whole lot of like processed stuff. So it was like all fresh breads and stuff like that. They were from bakeries, not pastries. As much as I love them. Cryptomathician. Good evening and welcome. My name is Obi-Wan Pez. This is N Simplex Pachinko, my home for mathematics. So, I studied mathematics at the University of New Hampshire for my undergraduate and graduated with a BS in mathematics education at the secondary level, and went to the Johns Hopkins University Applied... Yeah, sure, I've already said that. The Applied Physics Lab, which is in Laurel, Maryland. It is not on the main campus. So they had like this night school program, which was really cool. And my spouse and I did like a 2-for-1 deal. Not officially. She was paid by her work to get her master's, and I was not. So she was able to get 100% coverage, and I got 0% coverage. So it's like a 2-for-1 deal. That's totally how you do it. So not quite. So she did hers in computer science, and I did mine in applied and computational mathematics, because apparently I really like long titles on my diplomas. Yeah, that's what attracts me, I'm sure. So I was technically an applied math student, not a pure math student. And she was a computer science student. Although I will say we had one class where we overlapped. That was weird. All right, we have one class where we overlapped our schedules. We did have a couple of other classes that both of us had to take, but we just took it at different times. One was combinatorics, which was really cool. The one that we took at the same time was neural networks. And that was such an amazing class. Between the excuse me. Between the just the content itself, and also like bouncing ideas off of each other, like her from the perspective of computer science and me from the perspective of mathematics. Now, granted, she was also a pure math student in undergrad, so like I had some catching up to do before I was really on the same level with her mathematically. Because again, half of my degree was education. I'm still catching up on some of the stuff. Yeah, computer science was fun on that. Yeah, imagine. So the people who wanted to do computer science were mostly into programming in general. And for a lot of them, it ended up being that, yeah, they can get into programming and doing whatever they wanted in programming. One of the problems with computer science lately is that like some of the smaller colleges and universities will say like, oh, you need to have like a semester of Java, you need to have a semester of Python, you need to have a semester of whatever, and none of that stuff transfers to like larger institutions or between the smaller ones. So it kind of depends on where you go. And if you end up like going to an institution that requires you to know Python and you've been using Perl for the entire time, they're going to be like, well, you know, Python's a prerequisite, so you're going to have to like start all these classes over. Lately, like in the past couple years, we have discouraged that behavior and basically been telling the Fouriers that they need to like accept the fact that no, people have people understand the structure even though the language is different. Talk to your computer science talk to your computer science faculty. They will tell you that this is probably fine. They just need a refresher course. So like maybe they need one Python course to get them up to speed. But they don't need to like go completely from scratch. They don't need to go completely from scratch and like take all of the computer science classes all over again because they were just in a different language. No, that's not how that works. So So the first time that I saw esports as a college sport, I kind of chuckled to myself. Um, Being a gamer, it's kind of cool, but at the same time, it was like, well, that's not really like athletics. But at the same time, we've got all sorts of other stuff. There's a math team, right? There is a competitive math team, so why wouldn't there be an esports team? Call it whatever you want. It won't be like part of the athletic division, if you will, but it's fine. It's fun. Let's just do it. It's really cool. Our our college's esports did really well this summer. Like they had a summer competition among other community colleges and four-year schools that had other esports teams, and they did really well. It was really cool. Yeah. So two curbs. You right. Underlying all of it, there is. It doesn't really matter necessarily what the individual language is. You'll catch up on that. That's fine. But understanding the structure of how programming works is really the key, and that's what you really need for computer science, right? And I will admit, if you're doing like operating systems or something like that, okay, now you need to figure out assembly and all the other, you know, background languages. You need to figure all that stuff out. That's its own thing. Yeah, so the physics and calc prereq are they're interesting. Generally speaking, right, they should know science, but at the same time, like, yeah, so this is one of the things about me, for instance, is that I have I have programmed in like I originally programmed input output. I programmed TI. I programmed Texas Instruments calculator input output. That is what I did. I did BASIC way back in the day when our computers came with, or maybe my dad bought the software, whatever it was, but he bought, or we got the QBasic software on the original like DOS computer that we had, and we had to load Windows 3.1 like off of floppies. So my brother and I learned how to program in BASIC, and we had a magazine that was 321 Contact magazine. 321 Contact was a PBS show that was kind of science focused and to try to get kids interested in science. It was to science what Square One TV was to math. I like Square One a lot more than I like 321 Contact, but honestly, it was a really good show. I think I was just a little young for it, and then when I got older, I had a bias against it because I was like, oh no. And then also, 321 Contact was in syndication on PBS, So they were no longer making new episodes. So they were just coming up with using the old episodes, which were from like the 70s. So then I was like, it's an old show. I don't like that. Compared to Square One TV, which was newer for the time. It was still like, this is mid to late 80s. So the production value was a bit higher. I was born in the early 80s. That's as much information as you're going to get out of me. That might be a lie. You might eventually get one, but I don't typically share too much information on that, so you know how it is. Okay, so anyway, we got 4 solutions over here. Oh, man. I do like a lot of the random music that existed in the 1980s. These days, yeah, that's my generation right there, man. Is I didn't even finish my thought. I'm getting to be old. So this is the thing about my like half generation. We're Zennial. We're those people who don't really identify either as millennials or Xers. We're the kids who had the original Oregon Trail on 5.5-inch discs in our Apple IIe computers at recess. We had our school had a class called telecommunications where we went over to the Apple IIe, put in a disc, and had it dial up into an email inbox and then sign off from the internet because it was a long distance call and it was going to cost us a lot of money. Pop punk? I don't know. So, like, I don't know where I put my musical taste. It's weird. I'd say, like, the stuff that I mostly listen to. Well, so nowadays, the stuff I mostly listen to is, like, prog rock. Which encompasses modern, Coheed and Cambria, Dream Theater. There's a few other good ones out there that I can't think of. I also have bought almost the entire collection of, or I think it is the entire collection, of Jason Charles Miller. The guy that we usually raid on Wednesdays, which of course, now that I'm streaming on Tuesdays, I can't raid him. Those of you who are going to be here on Wednesdays, by the way, I'm going to host JCM's channel. I'm going to host JCM's channel on Wednesday nights. So come on in and like say hi and give him some love because I really like him. He's a great guy. I plug in, so I plugged in my my USB stick into the car to listen to music. And it pops up with Jason Charles Miller, and I like turned off the random thing, so it just went along. It just like started playing his stuff, and my spouse looks at me and she's like, "I thought you hate country music." And I'm like, "No, I only dislike country music as a genre because of that like twangy sort of stuff. If you listen to like, my preference on country music is basically what JCM does. It's like rock, but maybe there's a country feel to it. That's fine. I can get over him playing more twangy stuff because like, okay, fine. It's not really my cup, but it's fine. I'll do fine with it. And the same thing was true with Garth Brooks. Like, I like listening to Garth Brooks because he's just got a great personality. I don't really like his twangy stuff all that much, but you know, he's fun. He does an awesome show. You know, like I'm trying to think of something. So like The Thunder Rolls is an amazing song, and I don't care. Like that is rock. It's country rock, sure, but it's rock, and it is amazing. And there was a video that they did of one of his live concerts where there was a thunderstorm like over there while he was playing this song, and like the rain is just pouring down, and it was a taped live show. It was just amazing. And they used that over his studio recording for like the official video for the song. It was great. Yeah, and like I think The Vessel or something like that, Sail My Vessel or something like that, is a soft sort of or it is country music, but it's not really twangy. So I can get over that. That's fine. I like it. And again, he's a good guy. I like his stuff. No, I didn't witness that. Let's see. My midday watching of The Price is Right was preempted by the news of the Challenger disaster. If that gives you an idea of how old I was. Yes, they interrupted my Price is Right. How dare they? But yeah, I was not old enough to understand what was going on there. But yeah, I do remember the Challenger. Okay. So 4 solutions. Damn it. Which are going to be inverse tangent of 1/3. The inverse tangent of 1/3, and that is going to be in the opposite direction, so that's going to be minus pi. Actually, plus or minus pi, because we've got both of them. Okay. The other two are inverse tangent of 1/3 plus pi, and the inverse tangent of 1/3 minus 2 pi. Okay, so those 4 are our 4 solutions for this, which means that x, right, this is 2x, is equal to all these things, which means that x is going to be equal to 1/2 the inverse tangent of 1/3, 1/2 the inverse tangent of 1/3 plus pi over 2, 1/2 the inverse tangent of 1/3 minus pi over 2, and 1/2 inverse tangent of 1/3 minus pi. So those are going to be our 4 solutions for this particular setup, and then we're going to have to find a calculator that has batteries in it. Cool. That's the 89. Oh well. Yeah, I do like lighthouses. It's kind of a family thing of ours where we're just like, absolutely, we love lighthouses. Just because we're from the Northeast, so, you know, New Hampshire, Maine, there's a lot of lighthouses in the area, especially when you start getting down around like into Massachusetts, into where Cape Cod is. They need a lot of lighthouses because there's a lot of rocky coast in that area. What do I think of geometry? Yeah. I think that geometry is an awesome science. I was trying to teach some of my. So we've got school has started this week for us. So we're doing a lot of the like introduction type stuff at the beginning of the semester, and there's just so much in the syllabus. It's just kind of sucks the soul out of you. um, um, yeah. So just talking about the syllabus kind of sucks. It's just soul sucking. So we were able to, at the end of class, get into a little bit of like, here are some things that you want to be keeping, lookout for, or what is mathematics anyway? And so we went through a whole spiel on, how would you define mathematics? What is it? What do you use? All sorts of stuff, which led into like, what exactly, what is it that you would call an expert in something? My so we go to a we go to a I don't know if I want to go there, but yeah, whatever, it's fine. We go to a Unitarian Universalist congregation, and so our minister has been talking about like intellectualism in general, and how like our this particular faith has always been based in intellectualism and trying to like reason our way through things, but at the same time this kind of excludes a lot of people who aren't really into that, or aren't into like the super in-depth like breakdowns of stuff. So we get there's a phrase that was used over the past several years where we were talking about like how much people knew about a particular like cultural group or group of people, stuff like that, where it was cultural competency. And she took exception to that particular word. I don't know if, I think she was quoting somebody else. Yeah, there's a book. So she was quoting a book and saying like, you don't want to be competent in something in particular, because it kind of implies that there's like a bunch of boxes to check, and once you become competent, where do you go from there? And not to mention, once you become competent, like the landscape is going to change. And so I decided to take this and say, like, instead of a cultural competency, this is the same for any intellectual pursuit that exists. So if you go out there in the world and you decide that you're going to you're going to talk about the fact that you are aware about a particular topic, you don't want to just be competent and then be like, oh, I've got my master's, PhD, I've taught for N number of years, I'm an expert in this now. I don't have to really. The thing that one of my students had brought up was, oh, well, at that point you might think to yourself, you don't have to try anymore because like you're an expert in your field. I was like, bingo. You do not want to stagnate and get into this habit of thinking, "Oh, I'm an expert. I don't need to do any more work. Everything that I do is going to work on a like teaching level, right? I know all of the methods that I need in order to teach this thing." I told them like every single semester I learn at least one new way to do something. Yes, absolutely. And so our minister was saying that the alternate phrase, and again, she pulled this from this particular book that she was reading, the phrase that we're looking for is not competency, but rather humility. So having a humble nature in order to understand that we will forever be standing on the shores of knowledge, looking out into the ceaseless seas and thinking to ourselves, there is always more for me to learn. There is always more for me out there somewhere. And I just need to go find it. I need to go explore. So, Blayland, in terms of wild animals, I do rather like seeing moose as long as they're nowhere near the road. Being from the northeast, moose, one of my friends had a scare because, yes, cryptomathematician, absolutely. This was another thing that this is one of the things that my instructors in karate had said, my instructors in math had said, my instructors in education had said. It's pretty much once you reach that goal, once you reach that like your degree, or in karate, once you reach black belt, this is where your learning begins. It is not where it ends. This is where it begins. And I've really tried to take that to heart as much as I can. Yeah, Blayland, you don't want to know how many hours of sleep I get. I don't think I want to admit that out loud. The moose in Alaska are pretty awesome. We were actually able to go to a rehab center and feed moose bananas. We fed bananas whole to a moose. And my spouse was able to kiss a moose while they ate the banana. She was able to bend down and kiss the moose on its nose. So obviously pre-pandemic. Yeah, the moose are really scary in New England because most of the time what you see at night is posts in the middle of the road. There's just posts in the middle of the road, and by the time you realize what it is, it's too late. If you're on the highway. So you have to like forever be vigilant and notice that, like, this is why people have high beams on the highway. Because most of the time you're alone on the highway, except for maybe a moose. But they'll be driving down the road, and like I said, you see posts in the middle of the road, and it's like, what's that? Oh no, those are the legs of a moose, because the moose is above where your headlights are going to reach. Yep. So one of my friends had a scare. He realized too late that it was a moose, and like basically dove down across the center console, The moose had its legs taken out. It landed on the car, which fortunately he slammed on the brakes, and he smashed into the moose smashed into the hood of his car and came back, cracked the entire windshield, brought it in and down on him, but the moose did not come in on him, so he was able to walk away from that one. But yeah, car was just completely wrecked. Yeah, so I used to get 8 hours of sleep, and then late high school into college, I transitioned to about 6. And then when we moved down here, I kept up with 6 for a long time. And it's kind of kept slipping. Especially after we had kids. Like, basically every, like, life change that's been going on, I've just been getting less sleep every time. On one hand, I just need to stop being on the computer after like 11 o'clock. It'd be fine, even 10. It's already 10:40. Yep. So for a long time, it was basically like, no. See, this is the thing, is that they don't need 1 hour of sleep per day. They need about 4 to 6 to really do well. It's just that they end up getting like little naps every so often. And they won't admit to it. Who was it? It was Buckminster Fuller. He used to claim that he would only get like 1 hour of sleep a night, and no, that was BS. He used to sleep in his office all the time. People would catch him and be like, eh. And then he would do some work and talk with people and have meetings and all that, and then he'd wish them goodbye, do a little bit more work, and then fall asleep again. So he was getting like 4 to 6 hours of sleep, but a lot of it was during the workday. But the other thing was that he was actually doing work at night. Like, while everyone else was sleeping, he was actually doing work. I mean, that's one way to go. Alright, so let's see. If we were to go into... What mode do I have? I'm on radian, so that's good. Let's get decimal approximation for these. So... Inverse tangent of 1/3 is going to be, oops, half that. 0.160875. There's more to it than that, but nonetheless, 0.5 times inverse tangent of 1/3 minus pi is going to be, there we go, a negative 2.98072. Yeah, so cryptomathician, I know I didn't exactly say goodbye, so sorry. Have a good night. See you later. Thanks for stopping in, and we'll see you again later. Wednesday nights are... Damn it. Tonight is Tuesday. Tuesday nights are going to be math streams, and Friday nights are going to be game streams. We have just finished Return of the Obra Dinn, and must say, liked it quite a lot. Oh, did I just did that again. That one needs to be over 2 as well. Yeah, knew I forgot something, right? So negative 1.40992. Alright, give me 1 second here. Give me 1 minute, I'll run an ad. Okay, so it was the other one. Yeah, the answer I put into the first one where I forgot to put the 1/2, I forgot that's just the other negative solution. So I did read something, and this is, old information. So who knows? It may have changed since then. But, like, yeah, see. Um, one of the things that I read was that people who sleep less than 6 hours a day tended to have a higher instance of heart disease when they get into their, middle age to elderly years. And those people who slept 10 hours or more tended to have um, uh, other problems. So I think the one that I was looking at was there was respiratory issues. So like not specifically like asthma or anything, but um, like they'd end up having instead of heart disease, it was like they would end up having a higher instance of respiratory failure. I don't know, but there was something like that. It's been a long time since I read that, and I need to probably look it up again because again, information may have changed. All right, so these are going to be the four solutions that we get. I mean, it doesn't mean that, you're definitely going to have a problem. It's just you might. Tended to have a higher incidence. That's all it really means. And this could also be self-selecting. It could go the other way, that people who have this particular genetic, disorder to get this particular thing may end up just sleeping more. So it could be a, chicken or egg sort of thing. Don't know which one it is. It's not that more sleep caused it. It's more like this thing might have actually caused you to sleep more, and it was an indicator rather than a, you know, it's an indicator rather than a causal link. But whatever. Don't imagine you're going to be living long. I'm sorry. I hope you're wrong. Okay, so these are the zeros for the derivative function, which means that we need to plug them into the original one. Oh, dude. It may seem like that, but there is always room to become more nuanced and to do something else with your life. Now, it may kind of suck right now. Believe me, I understand. I went through several periods of complete suckage. But, and please, talk with someone about it. Not just me, right? We have a kind of one-way communication. And I know we do have two-way-ish communication, but so, Blainlin, I'm very sorry you feel that way, and I hope that you find out that you are wrong in a nice way. And I hope that you can talk with someone um, and get some sort of uh, you know get some sort of help from someone who talks about this sort of stuff like for a living. I don't want to use the awful phrases, right? There is absolutely nothing wrong with going to get help from someone, from going to talk with someone. We need to normalize this. Um, I have I have been meaning to set up appointments for everyone in the entire family to at least go talk with someone about just shit going on. Because quite frankly, I probably need a better organization to my thoughts and to understanding who I am on the inside. I need to bounce ideas off of someone in order to better understand myself. And that sort of thing, I will openly and proudly say I will go see a therapist. I just need to actually plug my name into the thing online and go do it. Yeah, that's another problem. Is just like healthcare generally kind of sucks. And like individuals are kind of great on it. When I'm president of the world, let me tell you. Um, and that's the other thing is we need better ways to communicate with each other, to create communities, to get together with people and just hang out and talk. You know, you like knitting? You like crochet? Let's do it. I know neither, but I am willing to learn. Right, and like we're pretty close to I don't know 3 dozen people. We have had a neighborhood party every so often because the people whose house our kids hang out at a lot, they like set up a bunch of stuff in our little tot lot, and they're just like, come on over and ask a few people to toss in. So it's actually like a we live in a horseshoe, and so it is a um, I don't think I know the difference between road and street. Is a road terminating? Is that kind of the point? Um, so yeah, it's a horseshoe with a double cul-de-sac. Yeah, you don't have happenstance encounters with people in a car. You don't talk much with people that you're just walking near either. But at the same time, you will have a happenstance encounter with just people around if you're like, hey, I live 2 streets over, how are you? And, you know, just go for a walk. That kind of thing. Go to people with kids, right? We've got 2 kids. Their ages are like, beginning of elementary and getting toward middle school ish. And like it's great to have kids in those age ranges because then you also meet parents who are in the same age, whose kids are in the same age group ish. Our next door neighbor has a kid that's like between ours. You know, people on the other side of us have a kid who's older than our oldest, and the ones down the hill have one that's our daughter's age. So like they're also connected through a couple of other things, and yeah, so that's nice. Okay, roads are made for going fast and making few stops. Streets are made for making stops and easy transport. Okay. So we're in this really weird place, and I can't do anything without doxing myself, which eventually it's probably going to happen, but nonetheless. We're in this really weird place in suburban America where basically you can't get anywhere without spiraling outward. Not a literal spiral, but like but like getting out through this maze of little tiny streets to get to a main road. And like we have and then what you're going to do is go to the main road, go to where you want to go ish, and then spiral inward until you get to the one street you want. Again, not everything is like this, but like nobody lives on the main road. Nobody lives on the immediate side street. Everybody lives on like the secondary or tertiary side street. So I think this is kind of like the new thing for America in terms of like since the 70s-ish, 80s, 90s. 80s and 90s especially. Yeah. Everything in our entire lives at the moment is set up for like profit and not caring at all for anyone. For not caring at all for anyone's mental health, for caring about anyone's well-being or nature or anything. Now, people are doing better in the last 5 to 10 years in terms of trying to make new constructions fit with the landscape rather than changing the landscape to fit the new structure. Now, granted, you can't put a building where a forest is, and sometimes you need to do that. But at the same time, they're going to put something in which is going to like mitigate the problem. Okay, they're going to put the building in, but then they're going to put up new trees immediately surrounding it. Not as many, but you know, some. Or they're going to replant a new forest somewhere else, where there perhaps was one a long time ago. Or maybe there's just a big field somewhere and they're like, well, nothing's being here, so we'll just plant trees. Especially if they want to get some sort of usage out of that someday in the future. Our college has done a pretty good job of trying to not only mitigate like carbon, but also trying to look forward and saying like, okay, 20 years in the future, 20 years in the future, what are we going to need? And coming up with a big master plan, which does get changed every like 10 years or so, but still having kind of the same effect. Saying like, okay, 20 years from now, this is what we want, and we're trying to meet the goals of the previous master plans, which are, you know, going okay. I'd say that's a highway. But yeah, if you've got a bunch of traffic lights, right? I think that's what you're going for. You're moving a lot of volume of traffic, but at the same time they have to stop every 500 feet or so. Quarter mile. Okay. Let's store this to, sure, let's just use the variables that are default on my calculator, so negative numbers, we'll keep that. Higher positive, keep them like that. And larger negative, like that. All right, Amogus, have a good night. See you sometime later, maybe next Tuesday or perhaps Friday. I think this Friday we're probably going to stream some maybe Elite Dangerous, because again, we've still got the event going on that people are trying to figure out what's going on. I'm not particularly good at it. I'm probably not going to find anything interesting, but we need to do some BGS work, the background sim, which is the thing that Psyche is trying to do, is move her corporation into a particular system where we have like something that we want there. And so what we need to do is make sure that a different the corporations that are in that system are in there. There is an empty space, and there's a certain setup in the way that all of their influences are set up. So essentially we've got to boost our influence in the home system, which we've done. We've got to go to the new system and start like really messing with this one particular corporation in order to make sure that they drop low, but not too low, and so that will be the priority system. We'll have a higher chance of moving into that particular system. So we'll see how it goes. Nobody knows. We have a bunch of estimations which we think are how it works, but I don't know. Alright, there is a new chapter in Azimuth Biotech, so I'm going to have to read that article in a bit. Anyway, so these four numbers then are going to have values inside of our function, which if we plug that into y equals, again, this is 4 times e, oh no, oops, oh, raised to the negative x, okay, times sine of 2x plus 2 e to the negative x times the cosine of 2x. Okay. Looks good. Okay. So if we graph this, I should get something that... Really? Oh, is it E? Is E the problem? Alright, character. Math. No, those are all special characters. Those are not... Oh, wait. E? Yep, that's it. Okay, so there's a special character. I can't just use the E that is in the... go figure. Can't use the E that is in the alpha stuff. I have to use the E that is in the character menu. Oops. Okay, so graph. Awesome. So, when we get this thing, okay, gonna quit. Now that we know where those locations are, we're going to take the original function of y equals 4e to the negative x times the sine of 2x plus 2e to the negative x cosine of 2x did the derivative right? Yeah, okay, cool. Always got to check. Okay, so once you get this, now we're going to say, based on that, we're going to plug in the individual values. So y of each of these numbers, this was a 0.160875. This was negative 1.40992. Oops, not comma. This was y of negative 2.98072. And nope, y of 1.731670. Okay, so if we go like y1 of x, this should get us a value. Yep, cool. 2.69236. And again, more stuff after that, but we'll just let it go. Y of 1.73, nope. That's y. 1.73, okay. So y of 1.73 is going to be negative 0.559686. Some of these may be rounded, where instead of the ellipsis being the rounded number, I should have it be the actual value that's showing up for the expanded decimal, but I just don't have time for that right now to, go through and check all of it. All right, negative 12.9515 here. And t, 62, yeah, 62.303 here. So if we want the values that are between negative pi and pi, which have extrema values, these are they. So that means that we could also, this is one of the things that I was taught in Calc 1, was draw a little diagram. We don't have to be specific about this, but yeah. Really? Okay, fine. Alright, since we're only going to negative pi, even it up. Alright, pi over 2. That's not what I wanted, is it? No, it is. Okay, because we want to plug into a trig function. There we go. Alright. So, 62.3 is just going to be off the chart. I'll leave it there. Also, it's not quite there. It's more like here. But whatever, it's fine. Negative 1.4 is just before negative pi over 2. And we have a value of negative 12.9. So it's like close down there. 1.73 is going to be beyond pi over 2. And we have a value of like 0.5, negative 0.5. So it's pretty small. And then 0.16, we have a value of 2.69. That's pretty close to a third. Maybe closer to a fourth of the way over to pi over 2. So somewhere in here anyway is 2.69. Okay, so what we get is something that looks like this. Okay. So we get something that looks like this, has an endpoint up here. Goodness knows where that is. And we have an endpoint down here. Oh, I never got back to you. So, I know you're all gone at this point. However, if anyone is watching this on demand, the question that I posed earlier was, why do we need to separate this into two cases? Why do we need to take the derivative and then look at that over the open interval and then plug in the values for negative pi and pi? And the answer is, where is it differentiable? So functions, generally speaking, are not left differentiable or right differentiable. They are differentiable or they are not. Their limits occur from both sides, and so that's that. Anytime that you have a discontinuity, which is stopping us from taking the function back through that given point, then we're going to have something that looks like this. All right, now how did I know that this is the picture? How come this can't be a maximum and it just goes down instead? Well, there's no other discontinuity anywhere in this, right? We've got a bunch of sine and cosine functions. Those are, sine and cosine functions are existent everywhere. All right, and then here, this peaks at negative 2.98. So that means that it must come down beyond negative 2.58 in both directions. Okay. So this is our negative 2.98 by 62.30. This one here is our 0.16 by 2.69. This one is 1.73. That is not 1.73. Oh no, that's pi. Obviously. .73 by negative 0.56. That point right there. This is going to be pi comma something we don't know. This one is going to be negative pi comma something we don't know. And this one is our negative 1.41 by negative 13 point, nope, 12.95. Okay, so when we go to the graph, we should be able to calculate from here. 5. Okay. What's the value at pi? Okay, so pi, comma, 0.086. And negative pi, I don't have it on the window, so yay, x min -4. All right, so negative pi has a value of negative, nope, that's positive, 46.28. So in this case, you have local extrema, which there are going to be an unlimited number of them. So these solutions, again, will map to future and past periods. We only really care about negative pi to pi, so we'll stick with that. And those are our solutions for just having local extrema. Which category do they fall under is the next bit, right? So, cool, but we have local minima and local maxima. Okay, local minima are going to be these two here. And local maxima are going to be those. Now, the endpoints become a little bit different. Normally, when you're looking for an endpoint, specifically one that has if you're looking for a local extremum, typically what happens is you've got one of two things. One is that you can say, well, it is pi is continuous from the left. So it's continuous and differentiable from the left. So in that way, you could have a local extremum, but it would have to be under this particularly careful set of conditions. You have to define it very carefully. All right. The global minimum global max is going to be this one here. And global minimum is going to be this one here. Now keep in mind, we are restricting this over this domain from negative pi to pi. So we're saying for this domain, there is a global min and global max. For the domain of the entire function, there's going to be neither one of those because the mins and maxes go on out forever, oscillating higher and higher and higher as we go off to the left. So the endpoints, again, you're going to have to ask your particular teacher exactly what they think about it. I think that they should count as local extrema from one side. So you can explicitly say that, and you should be able to get some sort of credit for it. But they are not going to be global extrema at all. All right. Let's find somebody to raid to. All right, got Cult of the Lamb, Dungeons and Dragons, Among Us. Just chatting for now, but A-Trey's doing a stream for Metal Gear Solid 4. Oops. Okay. Let's go with Res 501MK. Who is playing Final Fantasy VII. So we're going to head on over, give them a view because they currently only have 2 people there, and let's go strengthen up that channel. So, hope you all have a good week. Have a good first week back. Those of you who are in school this week, go out there and take care of yourselves. Love each other. Love yourself. And I will see you on Friday for games and next Tuesday for more math. So, have a good one. This is Obi-Wan Pez for Ensign Plex Pachinko. Good night.